Good morning, you guys. Today, let me fix my microphone a little bit. I know the volume always drops right away. Um, all right. So today in our next lesson, actually, this is our last lesson in our stoichiometry unit. We are going to be talking about percent yield. So in a video the other day, I told you that what we're coming up with is theoretical. Okay. And this is just based on the stoichiometric numbers, our coefficients, um, what we theoretically should produce. In the lab, reactions aren't as efficient as they should be. And things don't always happen exactly the same way that we predict that they will. And there's a lot of different things that impact this. Ambient temperature in the room, wherever you're at, is one of the key factors that affects the efficiency of a reaction. Or it's all based on how much those molecules are bumping into each other. And if there's just not as much bumping into each other, if those atoms aren't colliding in any way, and there's no interaction between those, what we're going to call Coulombic forces, which we'll talk about if you take AP. If there is no interaction, if those charges aren't interrupted in any way, okay, then the bonds don't break, and so we don't get the same amount of product. So, for the purposes of this class, that's as complicated as it's going to get. But I'm just going to tell you what we produce in the lab if we were to do a reaction is usually less than what we predict. So we're going to talk about today what we call percent yield. All right, so the goal of today, we're going to calculate percent yield of a reaction. All right, so, all right, what is it? Well, let's talk about theoretical yield, and I just kind of explained that, but it's the maximum amount of product that could be formed from a given amount of the reactants. And we get this from stoichiometry. This is what we've been calculating this entire unit, all right? Based on the amount of reactants we have, this is how much product we should get, okay? That's what we've been trying to figure out. Now we're going to start looking at what the actual yield is. So what is the amount of product that actually forms when the reaction is carried out in a laboratory? Um, a key in these problems is you're going to have multiple things in your prompt that you're going to have to be able to pull out multiple pieces of information, and we'll talk about some words that will help you identify when they're asking for actual yield or percent yield instead of just the theoretical yield. So this is our equation. Percent yield equals our actual yield over our theoretical yield times 100. Okay. Percent yield is a measure of the efficiency of a reaction carried out in a laboratory. So let's just jump right in. Let's do an example. So it says, what is the percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with an excess of copper 1 sulfate? All right, so we have an excess of copper 1 sulfate. They give us 1.87 grams of aluminum. Here is our equation, which we have to balance, so we're going to. And in order to balance that, we had, here, let me go back. I did that really fast. Okay. So, looking at this equation, I can quickly see that it's not balanced. Okay. I have 1 aluminum here. I have 2 aluminums in this molecule here. And then I've got 3 sulfates and only 1 sulfate. So it's like, and 1, anyway, I look at that and I'm like, oh, it is not balanced. So I'm going to start balancing it. And we end up with 2 aluminums, 3 copper, 1 sulfates, 6 coppers, and then 1 aluminum sulfate as our product. So, all right, so now we have it balanced. Now we can go on to what we need to do. We're going to start off with how much would be predicted to be produced with when we start with 1.87 grams of aluminum. Okay, we have excess copper, so that tells us that the aluminum is a limiting reactant. We're given grams, we got to turn our aluminum into moles. So we use our molar mass. We use our mole ratio of aluminum to copper, all right? Because that's what it asks. So in the beginning of the question, up here, it asks, what is the percent yield of 4.65 grams of copper is produced? So we're trying to look at copper, and it gives us aluminum right here. So this is the ratio we want to look at, is the aluminum to copper, all right? and we have 2 moles of aluminum to produce 6 moles of copper. Okay, so we do that. And we got to turn that back into grams. So we use a molar mass of copper, which is 63.55, and blah, blah, blah. Theoretically, we should have produced 13.2 grams of copper, but it tells us we didn't. It tells us we produced 4.65 grams of copper. So what we're going to do is calculate our percent yield, and we're going to put our 4.65 grams, which is what we were given in the question, it tells us that's what was actually produced, over our theoretical yield, which was 13.2 grams, multiply that by 100, and our percent yield was 35.2%. So hopefully that makes sense. Let's look at some context clues. So this is when you're given a problem, these are going to help you as you're reading the question to understand what they want. So, want to make, intend to make, is produced, is formed. These are telling you, these will help you as you're trying to figure out what the question is asking. And usually when these types of words are used, how much is actually produced, or how much is formed, or if you intend to make, whoops, you can tell whether you want, if you're looking at theoretical yield versus actual yield. In most of the questions I give you, I'm just going to flat out say, this is what happened in the lab, what should have happened, right? Or something along those lines. This much is supposed to be produced, but this is what is produced. Yeah, so that's that. All right. If you guys have any questions, go ahead and let me know. Send me a text or an email. Grading all those quizzes is taking me a lot longer than I planned. I was trying to print them all out, and my printer's being dumb, and then my internet was being dumb. Oh man, it's been a technologically frustrating week. My Xfinity actually went out, which my Xfinity is good internet, but like they had an outage in my neighborhood, and then my modem was reset, and yeah, it was a pain in the butt. But anyway, we got it figured out. So, all right, you guys. I hope you guys have a fantastic day. If you have any questions, like I said, let me know. We will probably have a test over this material next week. I will post some review guides probably Monday during our Zoom class. We'll go over a couple extra examples of different things. I'll post a review guide, and then next Tuesday or Thursday, we will have a test over stoichiometry. All right, you guys have a fantastic weekend.